Hello guys, and welcome to this second part of our introduction to the software tools that we will be using during our lab. In this videocast we will talk about MultiSim. MultiSim I think stands for multi-simulation or multiple simulation because we can simulate huge amount of circuits using this software. Of course there are many other software tools in the market, but we prefer this one because of its easiness. It's a very user friendly. You just place your components in the working area or the design area and run the simulation and you will get your measurements. Okay, so we have different toolbars. This is the standard toolbar of copying, pasting, printing and so on. Then there is the toolbar which you will be using the most, where the components are. From here we choose the components that we will be using in our circuits, and there is a toolbar for instruments. Now the idea of the multisim, actually it is a sort of simulation to the real situation in the lab. So you will be building circuits in the lab. You can build them in multisim first, then see what you are expecting to find in the lab. Okay, so I'll just show you a very simple circuit and measurement. The idea again is to break the ice with the program. We will be doing a lot of commands and a lot of simulations during our course. Now, to choose components, we can go to one of these groups. Here is the CMOS group, or the TTL group, or the amplifier group, or transistor group, and of course there is our basic group. In the basic group you can see resistors, capacitors, inductors, and variables ones: variable capacitors, variable inductors, variable resistors or potentiometers. There are switches as well. And when you click on a group or subgroup of the group, you can see a large amount of options. Values, in terms of values, in terms of manufacturer, in terms of tolerance. You can change the tolerance as you wish, and of course within the design itself you can change these values as I will show you in a second. The groups which are here can be chosen from this list as well. So we will make a very simple circuit: a resistor and a power source or a battery. So we take a resistor, click OK, and you get your resistor here. You can close. We can rotate the element clockwise, counterclockwise, it's up to you. And you can change the values and the name of the element by double clicking on the element. We can change the value, the tolerance, the label, and the way it is displayed. All of that can be done. We need a power source. We can go to sources and DC power source, for instance, choose it and paste it. Now simulations in multisim, they require a ground to be in every circuit, so we have to have a ground in the circuit as a reference point. And here they are, our first two elements which will form our first circuit. Now left click on the terminal of an element and drag. You will get a connection wire that can be used to connect elements together. Again, left click on the terminal, drag, and left click, drag, and there is our first circuit. Now, as I said, this toolbar contains the instruments, and these instruments which we find in the lab: multimeters, function generators, wattmeters, oscilloscope, multi-channel oscilloscope, baud plotter, frequency measurement devices, and so on. Most of the time we will be using multimeters. Sometimes we will use function generators, and sometimes we will use oscilloscopes. And those are the three main instruments that we will be using in the lab, beside the power source. If we double click on any of these instruments, we can find some of the more details, like which variables the multimeter measures and in which type of electricity. Is it AC or DC? Now this works for current and voltage. Resistance is DC only, and so on. The function generator, again, it gives you three waveforms: square wave and sawtooth and or triangle, and sine wave. You can change the frequency, the amplitude, and so on. The oscilloscope, again, it has the basic oscilloscope of MultiSim has two channels. You can see the background in black or in white. Now I think this should work on white. Okay, there is somewhere we can find it in white. Alright, so let's just connect our first instrument and do a measurement. Now from circuit class, we know that voltage source connected in parallel with a resistor should give the same voltage of the source on the resistor. So if we run the simulation, we are expecting to have a 12-volt reading, and it is giving it in dB because it is chosen in dB. We want voltage, so here is our 12 volts. Okay, now if we add another resistor here with the same value, of course if you want to change anything in the circuit, you have to stop the simulation first, and we want to remove this wire and add another resistor, I guess like that. Now if you are, we will be learning all of that, and you know that this is a very simple voltage divider which divides this voltage into half of it here and half of it here. Now if you run the simulation, we are expecting to have 6 volts on this resistor instead of 12, and that's 6 volts on this resistor. So this is how things will be done. You will be working with circuits on MultiSim, expecting certain values, then you come to the lab and build these circuits on breadboards and do measurements using real instruments and compare your results from MultiSim to your real results. Of course there will be a small deviation or drift, which is very natural because of tolerances and various circumstances in the lab. Thank you for watching.